Hello and welcome to Lesson 3C, where we talk about systems of linear equations in three variables. A solution to a system of equations with three variables is an ordered triple x, y, and now a new variable z, which makes all of the equations true when you substitute in. So let's look at an example for y'all to see this in action. Do you guys see how if I were to just simply add straight down on these first two right here, if I were to add these together, x plus y minus z equals 0 and 3x minus y plus z equals 0, if I were to add those together, the y's and the z's will cancel out. Sorry, that should be equals 4. So I get that 4x is equal to 4, or x equals 1. And now that I know that x equals 1, well, if I look at this equation right here, I've got 5x plus z equals 7. I can plug in x equals 1 and do 5 times 1 plus z equals 7, or 5 plus z equals 7, so z must equal 2. And now I've got an x and a z. All I'm missing is y. I'm going to plug into my first equation now. X plus y minus z equals 0, or 1 plus y minus 2 equals 0. When I move everything over to the other side, I would get that y, in fact, equals 1. So my final answer is the point 1, 1, 2. Now here's what's really important about this. When I take this point right here and I plug it back into my original equation, so I'm going to write this as a check. That point should satisfy all three equations. 1 plus 1 minus 2 does in fact equal 0. And 3 times 1 minus 1 plus 2, well, that's 3 minus 1 is 2 plus 2, in fact, does equal 4. So that one works. And then 5 times 1 plus 2 does equal 7, so that works. So this point satisfies all three equations, therefore it is a solution to the system of equations. Now this system was very easy to solve because we had one equation with only two variables, and two of our equations could cancel two variables at once. However, not all of them are going to be that easy. The best way to solve a system of linear equations in three variables is to do the following. Use one pair of equations to eliminate one variable using the addition method, and then use a different pair of equations to eliminate the same variable. So the idea is you should get down to two equations with two unknowns, which you know how to solve. You've got three methods to solve a system of two equations. You then solve for those two variables, and you plug back in to find the third variable, and you'll give your answer in an ordered triple form. Let's do some examples so y'all can get a feel for how this works. When I'm looking at these equations here, I've got 3x minus y minus 2z equals 12, x plus y plus 6z equals 8, and 2x minus 2y minus z equals 11. And I first want to choose a variable to eliminate from two pairs of equations. I'm really liking the y. The z would be pretty easy too, but the y is going to be very easy because they could cancel from these two really easily. And then they could also, if I multiply this one by 2 through here, I could cancel them here easily too. So I'm going to eliminate y. And I'm going to do first these two equations. So that's 3x minus y minus 2z equals 12, and x plus y plus 6z equals 8. And when I add straight down, I get 4x, my y's cancel, plus 4z equals 20. That's one of my new equations. Now I'm going to look at these two equations where I'm going to multiply the top one times 2. So that will become 2x plus 2y plus 12z equals 16, and I'm going to combine it with 2x minus 2y minus z equals 11. And when I add straight down, again, my y's cancel, and I'm left with 4x plus 11z equals 27. All right, now I have a new system of equations. My new system is 4x plus 4z equals 20, and 4x plus 11z equals 27. If I were to send a negative, I'm going to send a negative through the top, my x's will cancel. And here I'm left with 7z equals 7, so my z must be 1. And now that I know z is 1, I'm going to plug z equals 1 back into one of these two blue equations to find my x value. So I'm going to do 4x plus 4 times z equals 20, or 4x plus 4 equals 20, 4x equals 16, so x must be 4. Now I've got z, I've got x. I now want to plug into one of my three original equations to get y. I'm going to plug into this middle one, just because it seems a little bit simpler than the others too, to get my y value. So if x plus y plus 6z equals 8, well, x is 4. I don't know y yet. We got that z is 1 equals 8. That becomes 10 plus y equals 8, so y must be -2. So my final answer, the ordered pair, is x is 4, y is -2, and z is 1. Let's do a quick check to make sure that that works. Here's my check. I'm going to plug them all in. Does 3 times 4 minus -2 minus 2 times 1 equal 12? So that's 12 plus 2 minus 2 does in fact equal 12. Does 4 plus -2 plus 6 times 1 equal 8? That's 4 plus -2 is 2 plus 6 is 8. That works. And then 2 times 4 minus 2 times -2 minus 1, does that equal 11? That's 8 plus 4 is 12 minus 1 is 11. So that works. So this is my final answer. All right, guys, let's take a look at another one together. I know these are a little bit more complicated than we're used to. In example 3, I've got 3 variables again, and I want to figure out which one I'm going to eliminate. And just by looking at this, it looks like the x's are going to be the easiest because there's 2x, 1x, and 4x. So I'm going to eliminate x as my first variable. Eliminate x. But again, I could have chosen any of those 3 variables to eliminate. X just looks like the path of least resistance. And so I'm going to do these two together first, or I'm going to multiply the bottom one by -2. So this becomes 2x plus y plus 3z equals 9, and -2x plus positive 4y minus 2z equals -16. So when I add straight down, my x's cancel. I get 5y plus z equals -7. All right, and now I'm going to do, I think I'm going to do my top and bottom equations, or I'm going to multiply the top times 2 to eliminate things. So my top equation would become 4x plus 2y plus 6z equals 18. And my bottom equation is still -4x plus 3y plus 2z equals -4. And when I add straight down, the x's cancel just like I wanted them to, and I get 5y plus 8z equals 14. And so now I have a new system of equations. My first equation is 5y plus z equals -7, and my second equation is 5y plus 8z equals 14. So if I send a negative through, could either of them, I'm doing negative through the top one, so my y's cancel, and I get 7z equals 21, so z must be 3. Well, now I've got z, I can plug it back into either of these two equations to get the corresponding x value. I'm going to do, the corresponding y value. 5y plus 3 equals negative 7, so 5y is negative 10, which means that y is negative 2. So now we've got a z value, we've got a y value, I just need an x value. So I'm going to come up and plug it into one of these. I'm liking that one, doesn't matter which one I choose. And x minus 2 times negative 2 plus 3 equals 8. So that gets me x plus, that's 4 plus 3 is 7 equals 8. So I get that x is 1. So my final answer is 1, negative 2, 3. And now all we have to do is check to see whether or not we're correct. So we'll plug back in to see if we're right. And with some very quick plug-in math, which I've done up here, we can check and see that all of our equations in fact do work for that point. So let's keep going. Now this is a try me, and what I want you guys to do is I want you guys to first start off by eliminating the y variable. So first eliminate the y variable and tell me which two equations you get. All right, you should get the equations roughly close to negative 3x plus z equals negative 8 and 4x minus 7z equals 5. Check your math if you didn't get equations like that before you go on to the next step. All right, now I want you to figure out how to get z. So look at these two equations and figure out what you can do to get z. All right, so if you had multiplied your top equation by 7, your z's will cancel, which will allow you to solve for x, and you end up with x equals 3. So now take a minute and find the corresponding z variable given that you now know x. So I chose to plug into the top equation up here with my x equals 3, and that allows me to get that z is 1. So now you know x and you know z. Take both of those pieces and now do whatever you need to do in order to find the y variable. So I chose to plug into the equation x plus y minus z equals negative 1. So 3 is x, z is 1. When I solve this, I end up getting that y is negative 3. So my final answer is 3, negative 3, 1. And if you want to check your solution, and I highly recommend that you do check your solution, you want to plug those three variables into these three equations and make sure that all three work. All right, guys, the last thing we can do with systems of three, sometimes we're given an easy system of three where we can use substitution to knock things out. So when I look at these three equations, I know I can immediately solve the top one because that's just a one variable equation. So 5x equals 5 is going to get me that x is in fact 1. Well, what I can do now is I can sub that into my next piece. 2 times 1 plus y equals 4. Well, y must equal 2. So now I can take the x and the y and plug them in my last variable, to my last equation to get z. 3 times 1 plus 2 minus 4z equals negative 15. Well, that gets me 3 plus 2 is 5 minus 4z equals negative 15, or negative 4z is negative 20, so z must be negative 5. Or sorry, positive 5. Sorry about that, guys. Z must be positive 5. So when we plug it back in, 5 times 1 is 5. That works. 2 times 1 plus 2 is 4. That works. 3 times 1 is 3 plus 2 is 5 minus 20 is negative 15. So it works. All right, guys, take a look at the practice problems. Thank you.